Hello and welcome to part 1 of the series in which we'll go step by step in programming the Connect 4 game in Python. By the end of the series you'll be building this functional Connect 4 program. In the game you'll have the choice of choosing one-player or two-player mode. In one-player mode you'll be playing with the computer with an AI which we will be coding from scratch. The AI will be able to anticipate when you are about to win and take the appropriate action. Also, it will calculate the probability for which column to insert the token in order to increase its chances of winning. In the two-player mode you will be able to play with your friend. One will use the mouse to play, the other will use the keyboard. When a winner is detected, a message box will appear telling us who the winner is. Once you close the message box, the game will reset. In this video we'll start off by building the mechanic of our game on the console. We will include the GUI graphical user interface at the final part, so make sure to watch the whole series and subscribe to be notified when a new video comes out. We start off by declaring some char variables. Red will equal to an uppercase X, yellow will equal to an uppercase O, empty will equal an underscore, and player which will be assigned to red. Next, the board, which will be a 2D list with a dimension of 7 by 6, 7 columns and 6 rows. We'll give it a variable name board and will initiate its entire index with our empty constant. If you are new to Python, this assignment might look confusing, so let's break it down. This is a common use of a for loop to build a new list called list comprehensions. The inner closed bracket will execute the same result as this for loop, resulting to the following list. The outer bracket does the same thing, except it appends the result from the inner bracket to a new list, resulting to a 2D list which will be assigned to our board variable. Now let's create a function which will display the board on the console. We can achieve this by printing each row one by one. To do this we'll use a for loop with a range of the size of the row in a reversed order, and inside the loop we'll create and print a list that will represent the rows. Now let's call our display function, then run the program to see how it looks. As we can see, we have the empty 7 by 6 grid board displayed on the console. Now let's create a function which will let us insert a token in the board, and we'll name it insert, and we'll pass a parameter named column which indicate which column the token will be inserted into. Inside the function we will declare a variable which will hold the index number within the column list in which the token will be placed. The index method with our empty variable as the parameter will return the index number of the first occurrence of an item in the list that is equal to empty. Once we get the index we update the board. If the item is not in the list it will give a value error, so we need to wrap it inside an exception handling, and if it does catches an exception we need to tell the player to select another column. Let's write a few function calls to test the function. We'll pass the same value to the parameters to see if it catches an exception. As we can see, the function executes as we intended it to. Each token inserted rests on top of the previous token inserted in the same column, and if the column is full we get a message telling us to choose a different column. Okay, that looks good. So far our game does not have two-player enabled, so let's enable it. To do so is very easy. All we have to do is to toggle between the two-player red and yellow each time a token is inserted. We can achieve this with a simple if statement. Let's create a function and we name it togglePlayer. Inside we add the if statement that assign player equal to yellow if player is red, else equal to red. This function should be called after each insert function. Let's test it out. As you can see, the token alternates between red and yellow each time the togglePlayer function is called. It wouldn't be much of a game if we are unable to manually insert a token while the game is running. So let's create the getInput function, which will print a text on the console asking the player to select a column. When the player inputs an integer value and presses enter, the function returns that value. Now it's time to include the game loop into the game. We will just use a while loop to loop infinitely. Inside the loop, we'll place the display, getInput, insert and toggle player functions. We will pass the getInput function as the parameter for our insert function, so when the insert function is called, the getInput function is first called automatically and its return value is passed through the insert function. Inside the insert function at the catch exception, we will add a recursive function to allow the player to pick a different column if the chosen column is already full. Let's do a quick run to see if everything is running as it should. We'll have both of the players insert the tokens in the same column to test the exception which will occur when a player tries to insert a token in a full column. As we see, the program asks the player to choose another column when trying to insert at a column which is already full, and if the player chooses a different column, our program continues on as normal. So far we have the basic of our game coded. Now it's time to add the mechanic which will enable the program to detect a winner. To achieve this, each time a token is inserted, the program will search for 4 corresponding tokens along the vertical, horizontal and both of the diagonal from where the token is placed. We will write a separate function for each one, so let's start with the vertical check. Before we start coding the functions, we first need to come up with an algorithm for the task, and we'll use a diagonal check for a reference. One simple solution is to treat the board as a 2D grid with a coordinate 0, 0 at the bottom left. When a token is inserted, from the coordinate it rests in the grid, we take 3 steps backward. If we come in contact with the grid's boundary within the 3 steps, we'll stop there and we'll label the coordinate tail. Again, from where the token rested we repeat the same process, but this time we'll take 3 steps forward and label the coordinate head. Then we create a new list from values within all the coordinates between tail and head, including tail and head. Then from the list we just created, we loop through it to check if there is a 4 continuous token. If so, we have a winner. We start off with the vertical check function and we'll name it checkVer, and we'll pass 2 parameter, x and y, which represents the coordinate of the inserted token. This function will be the simplest out of the 4 because it requires the least calculation. Head and tail here are not 2D coordinate, they just hold the value of the y coordinate since we are only checking in the same x coordinate. Head will be assigned to the parameter value y. Since this is a vertical check, the token coordinate will represent the head coordinate. To get the tail value, we subtract 3 from the value y. If y is greater than 2, else 0, since subtracting 3 from y, when it's 2 or less, will go out of bound. Now we'll create a new list variable. We'll name it checklist, and it will be equal to the values within all the coordinates from tail to head. We'll then pass this new list through a function where it will check if there is a 4 connected tokens. We'll name the function checkConnection. Let's define the checkConnection function. First, let's declare an int variable which will keep track of the continuous token, and we will initiate it to 0. Next, we'll loop through the list we just passed as the parameter checklist, using a for loop. Each time the value in the current indexed list is equal to the value of the current player in play, our variable counter is incremented by 1. If they are not equal, counter is reset to 0. Finally, if counter reaches the value of 4, we have 4 connections, which means we have a winner, so we'll print a message to the console and break out of the loop. The program must check for a connection as soon as a new token is inserted into the board, so the function call for the checkVer will be added inside the insert function right after where the board is updated. Let's run the program. To test the function, we'll insert the tokens for the purpose of getting a vertical connection. As we can see, we have vertical connection from player yellow represented by the uppercase O, and the program outputs the text connected on the console, which shows us the function works. Next we'll create the horizontal check function and we'll name it check hor, and again we'll pass the coordinate of the token as the parameter. We calculate the coordinate value for tail and head with respect to our x variable. Using the values of tail and head, we assign the list variable checklist. Then we pass the list through the check connection function, where it will check for a connection in the list. Again, the function should be called inside the insert function. Let's run the program. To test the function, we'll insert the tokens for the purpose of getting a horizontal connection. As we can see, we have horizontal connection from player red represented by the uppercase X, and the program outputs the text connected on the console, which shows us the function works. The next two functions, check up slope and check down slope, which will check the diagonals connection, may look a bit more complex, but it follows the same logic as the two before. Explaining them in detail, I'll just be repeating myself, so I'll move on. Don't forget to make sure all four functions are called inside the insert. That's it for this video. On the next video we'll be coding the AI, so make sure to watch it. If you don't want to miss it, subscribe to the channel to be notified when a new video comes out. Until next time, thank you for watching.